Okay, on Tuesday, we talked about both Cartesian physics and, importantly, Cartesian philosophy. Remember, Descartes is a full-service system of physics, a metaphysics, and an epistemology, right? What we know, and why we know it. He built this system based on Galileo's laws, and we already talked about how revolutionary Galileo's laws were. So Descartes' vision of the world, likewise, is a radical departure from what went before. He articulated a total vision of the universe that was mechanistic. Descartes' system provides not just a total scheme for understanding motion and matter on the physical plane, but he also explained the nature of mind and the hidden mathematical order that exists on a parallel metaphysical plane. So Descartes gives us, well, this is the old one that was just spinning and getting nowhere. Okay, so Cartesian metaphysics and Cartesian physics are dualistic, two separate things. Remember, we had res extensa, that which is in the physical world, that which is extended, that occupies space by knowing its position, its size, its speed. You can graph it on the Cartesian grid that represents all of the physical universe. And res cogitans is the underlying mathematical principles that are the information that provide the blueprints that structure this material universe. It is also the principle of free will in an otherwise deterministic universe. And we're going to talk about that later on in the lecture, but it's an important idea because Descartes actually places free will at risk. And that is one of the threats we're going to talk about today when we talk about the mechanical philosophy. This is an orrery. It is actually, these are very popular. They started building a lot of them in the 18th century. And it is a model of the clockwork universe. Literally, they began just taking apart a clock, using the gears of the clock to suspend a physical model of the solar system that had been worked out in the 17th century. Now, there's something about a clockwork universe that just sums up everything Descartes and the mechanists were trying to accomplish when they wiped everything away that had gone before and gave us this reductive, mechanical philosophy, utterly comprehensible, utterly describable in terms of mathematics. If you look at a clock and you're looking at its hands going around the face of the clock, wow, what is moving those hands? That seems fairly mysterious. They seem to just be moving on their own. This is a fundamentally mysterious object, the clock. How does it tell time? I don't know. Then you open up the clock. All of a sudden, you understand that the hands are being pushed around, pulled around by gears and levers and pulleys. Everybody intuitively grasps mechanical motion. It's simply not mysterious. You don't have to bring God into it. You don't have to bring demons to explain bump in the night. If you go upstairs and then you see that, oh, it's something fell off, my husband knocked off the planter as he was coming into the room. Boom, it went bump in the night. Contact force, elbow, on base, hits the ground, makes sound, boom. Contact physics. Push, pull, no mystery. So you open up the universe, this universe that seems to be full. In the imagination of the 1500s and 1600s, this universe seems to be full of ghosts and demons and spells and enchantment and danger and devils. And where is God? When you open up the clockwork universe, there are no demons or devils or spirits. There are just pulleys and gears, logic and reason, contact, pull, push, motion, force. This is the model for the new age, the age of reason. And the age of reason is going to be led by a new set of men. these new reasonable men who are going to need new institutions to represent them, because hitherto, in the medieval age, the age of kings and knights and churches and Aristotle, they didn't have independent institutions. Remember, Galileo had to find defense with Cosimo de' Medici. And when he left Florence and he went to Rome and no longer had the prince's protection, he fell into the clutches of the church. There was no really strong, independent institutional space that could offer him protection. And that's why these new philosophers who are imagining this new world, this new age of reason, to be guided by what? Descartes' reasonable, rational epistemology. And the new institutions they're going to found, and we already talked about this a little bit yesterday, so I'm just going to touch on it again briefly, are the new scientific societies. We get these established in the middle of the 17th century. Interestingly enough, look at the earliest society, the Academy of Linces. That was the Italian society, because quite frankly, the Italians, in terms of natural philosophy, the site of the Renaissance, the place where you had all this wealth from manufacturing and the wealthy princes sponsoring competitions with each other's states in order to produce the most knowledge, the most beauty, the biggest palaces. Well, intellect, philosophy, art was thriving. Part of that was natural philosophy. And yet, look, 1630, the Academy of Linces is shut down. Galileo was a member of this academy. And so where science was clearly, in a way, burgeoning in Italy, it was perhaps it's the leading edge of this kind of philosophy. Once you get the church stepping in and saying, science is dangerous, science is in conflict, the first thing it does, right, is it bans the books it doesn't want read, and it unplugs the nascent institutions like these new scientific societies that are trying to establish a space outside of their control. So they're going to control this secular space, this intellectual space, this philosophical space that is going to be the womb of science, and that's why science ceases to significantly develop in Italy, because they basically, killed the space, killed the womb where it would have been hatched. Royal Society of London, we talked about yesterday, and the distinctive thing about this society is that although it takes the king's title, it's royal, it is largely financed independently, because these individuals know we are not the creatures of the church. We are not the creatures of the state. We serve, and here you have the ship passing through the pillars of Hercules into the unknown, guided by what? Only reason. Who are masters of reason? Why, we are, the mathematicians and the natural philosophers. So who is going to take us out of the past and into the future? It's not going to be those traditionalists like kings and priests. It's going to be the natural philosophers. So they make sure that they are charting the course of science. And where are we going to see science flourish? To the greatest extent, this is going to be a course that plots its way through Great Britain. The story of science is going to start to converge with the history of Britain, the intellectual history of Britain, because of these institutions that are being put in place. One of which, of course, is going to be the Royal Society, but culturally, it's going to be what we're talking about today, the Newtonian synthesis. So the gateway of Newton is going to be the gateway through which science passes into the future. The Académie Royale des Sciences is the French society. That is actually under the control of the state. And Louis XIV, probably heard of him, pretty autocratic guy. And so even though he wants to make sure he has the best of everything, the best natural philosophers, the most prestigious academy, at the same time, it's not science for science's sake. It's not embarking off into the unknown, plotting a course based solely on reason. science is going to have to jig along, right, with the agenda of the state, because who's controlling the money? The state is. So science is going to be secularized to a certain extent that the French state is, but to the extent that it's not, and at this point, Louis XIV is very Catholic, science is going to be uncomfortably cramped in France in the 17th and even the 18th century, as we'll discuss next week, uncomfortably cramped between both religion and the state. These are very exciting times for these natural philosophers. They have this bold new philosophy. They love the fact that they exist in a clockwork universe, that they are uniquely empowered through their mathematical reasoning to understand. They are the new high priests of information. And yet, remember, the world in which they were born into is still an early modern world. And they've been asked to make radical reorientations that maybe they're not ready to. Maybe they're not as ready as Descartes to say, I think, therefore I am. And so even though Descartes is so seductive because of all his philosophy and his science has to offer, there's still something profoundly radical about it, and perhaps potentially profoundly unworkable. They might not be able to move forward with this science if this science is going to prove itself so radical, so antithetical to everything that went before. If it denies or defies any possibility of synthesis with traditional religious values, will it be able to move forward? So on a lot of levels, Cartesianism, as great as it is very radical. First and foremost, the entire body of knowledge taught at the university level is Aristotelian. Are they going to have to pull every single book out of the university now and start putting Descartes on the shelf, making a god of Descartes, who, by the way, derived a proof of God from his own existence? Also, reduce creativity of the creator to mathematical dicta. This is a beautiful clock-like universe. It works in such a harmonious and mathematical way. But it's very reductive. Remember, you can understand this world if you understand algebra, and you understand speed, size, and position. You've packed God's mystery into a nutshell. And so in a way, this puts limits on the majesty and the mystery of God and is impertinent in the way it presumes to understand and reduce God's limitless majesty. Because if you are a Protestant or a Catholic, you would have understood God's majesty as limitless and his creativity as limitless. And you would have understood one of your primary ways that you relate to God is through the emotions of love and affection. Salvation, as it is taught through the Bible, as it was propounded in ancient Rome and transmitted from person to person, was a powerfully emotional and personal, effective way of communicating, communing with God. And suddenly, this religion is supposed to regraft itself onto a Cartesian grid. So remember, at the time of the Reformation, even though in some ways they were trying to rationalize religion, get rid of all the hocus pocus, the magic, the demons they felt had accrued and corrupted on the theology of the Catholic Church, they're trying to rationalize it to a certain extent. It is still a very spare and very simple philosophy. All the power of the universe is focused in God's hand. If you want to be saved, you do it in two ways. Sola fide, sola scriptura, not sola rationality, right? So you're going to have many of these Protestants who are in the North who have the freedom to reject Catholic Aristotelianism, who are hungry to embrace this new mechanical science, are still going to be looking at it and saying, well, part of my mission here on earth as a natural philosopher, remember, this is how people thought. They would have thought of natural philosophy as continuous with a kind of natural theology. You don't try to understand these things as fundamentally separate. So a religion that is purely rationalistic is irreverent, that is purely rationalistic is unemotional, that is purely rationalistic is also an affront to the one thing above all else that Jesus said brings you to faith. The one thing, faith. Descartes doesn't need faith. Descartes has rational proof. The other thing is, well, God gave us this wonderful universe. He winds up the clock, right? You just wind up the clock runs by itself. We do need a God. Absolutely, Descartes needed there to be a God. In fact, you could say God serves Descartes' science. Like God is the handmaiden of science, and it's supposed to be that science is the handmaiden of God. But Descartes needs God. He needs a prime mover. He needs to put motion into the world, and he needs somebody to create the law and order for the world. But once he does that, once God winds the universe, he's kind of absent and kind of unnecessary. So this absentee watchmaker God is going to be a very distant, chilly kind of God from the emotional, intimate God they're used to. And another thing, Descartes' radical epistemology, I know that I know nothing. I can't trust tradition. I can't trust scripture. I can't trust anything. So he's taking that entire tradition of sola fide, sola scriptura, scriptural authority, and also making that an essentially invalid form of knowledge. The only knowledge that is valid in his epistemology is the epistemology based on il cogito. Now, that's all the potential threat. Intellectually, this threat is crystallized. It is fully realized in all of its sort of nefarious potential in Thomas Hobbes. So you all probably have to read Hobbes and Locke in high school. So you're kind of familiar that Thomas Hobbes is the sort of authoritarian bad guy to Locke's liberal, individualistic good guy. And Thomas Hobbes is looking at Descartes' theory, and for the most part, the physics. He loves the physics. Hobbes loves cracking open a clockwork universe and seeing just gears and pulleys. And he's so absolutely convinced that this is the fundamental nature of matter, that matter is in fact, well, physics, all reality is in fact matter in motion. And if you think that is the fundamental reality, that you got to predicate a brand new morality, a brand new religion, a new kind of politics, a new kind of state, a new kind of anthropology. This is uncharted territory. Because now we were used to science and religion trying to formulate an understanding of nature and supernature. But now science is going to step into a new secular space and think, can this science, can this natural philosophy, this mechanistic philosophy, can it be the basis of social thought, of political thought? Can I engineer society and morality and ethics along the lines of science? The first people to do that, of course, this kind of secular ethical reasoning, secular political thought, was in the antiquity. We had all those Greek ethical philosophers, and like this kind of political thought that we see with Hobbes and Locke, it comes in the wake of natural philosophy. So first you had the pre-Socratics rethinking a naturalistic world filled with deterministic laws and order and motion. Once they get the new view of the world, then they get the ethical system that they need to formulate based on this new understanding of nature. Same thing is happening again. So even when we look at this new secular push of scientific reasoning into the political, into the social sphere, and this is important because they're going to now, out of this thinking, is going to come the Enlightenment. We've seen it all before. This is all preceded by antiquity. So what are the elements of this new philosophy? Hobbes tells us. Well, the first problem that we get with Hobbes is that even though he loves Cartesian physics, he takes a look at it and he says, you know what? I love the idea of his mechanics, all reality is matter in motion, but what I don't need is res cogitans. I don't need that thinking part, that metaphysical part. I'm just going to keep the material part. because I don't think mind is separate from matter. I don't think mind is some a priori divine principle. I think mind is a function of matter. I think consciousness, your consciousness arises from the push, pull, clang of your, he wouldn't have said necessarily brain cells, but of matter in motion. So rather than matter being an extension of ideas, thought, mind, he reverses it. And matter, in fact, is the a priori to mind. That's materialism. He just snapped off the metaphysical aspect of Descartes' dualism. Dualism has just become monism, just one thing, matter. It's become a chilly, chilly, godless, spiritless world that that Hobbes is going to tell us about. So now, what are the sort of things that you lose? Well, you lose that whole ridiculous notion of I think, therefore I am. The whole epistemology, in a sense, based on I think, therefore I am. If you think thinking is just a function of your body, then you might as well say I skip, therefore I am. I drink, therefore I am. This is just a biological function. So I think, therefore I am becomes a sort of ridiculous notion, no different than you exist, therefore you are. So he exposes a sort of absurd tautology of both Descartes' il cogito, but also remember, from I think, therefore I am, Descartes derives his proof of God. So now Hobbes has taken out both metaphysics and proof of God, and another thing he's taken out. We know there can be no free will now, because matter, according to Hobbes and according to Descartes, is determined by specific laws, push-pull mechanics, totally quantifiable, totally determined. It is a machine. And the only principle of free will that we have is the divine aspect of our minds. So if he just told us there's no divine aspect of our minds, we're just bodies. We are just machines. Talk about a radical, unswallowable idea. Talk about a scary, atheistic boogeyman. The whole principle of Christianity, one of its most central tenets, is you freely choose salvation. Free will is central. And now this materialistic philosophy, which has pushed God out of the universe, has turned us into robots. So it's not only very friendly to God, it's not particularly friendly to humanity as well. And this is what it would say about mankind. Oh, I know you think you're freely choosing, but you're a robot. And this is the nature of your programming. You are programmed to do that which brings you the most pleasure, and you're programmed to avoid that which brings you the most pain. Therefore, since you are a sort of impulsive, pleasure-seeking, out-of-control person who's not endowed with this noble reason thing, then you have to be under the strict supervisory control of the state, because the state is the only one that's going to make it more painful than it is pleasurable for you to break into your neighbor's house and raid the refrigerator, right? So all of a sudden, we get a Hobbes who's in for a strict authoritarian government, the Leviathan. Right? He writes the Leviathan. He wants a massive state because a man's unruly programming is to make him pleasure-seeking and self-gratifying. And then the other part of his program, he doesn't come right out and say there is no God, because you really can't say that in the 1600s and hope to survive the experience. But he does say anything that isn't sense is nonsense. Because we already know we don't have an a priori mind, right? All you have is your body and your senses taking in information, and then your mind is this apparatus that is a function of all these other systems. So if you can't see it, feel it, touch it, taste it, or hear it, it doesn't exist at all, because your senses are the gateway for this material reality. Now, what are the implications of that? Can you see God? Can you taste God? Can you touch God? Can you smell God? No. Well, according to Hobbes, then, anything you cannot sense is nonsense. There is no metaphysical plane. There's only physics, and our physical stimulation. Now, what is the political context? In this bold little shipwreck they're trying to call the Age of Reason, you know, that craft going out and over the horizon, daringly trying to plot a course into the unknown, what they didn't show is that ship rocking to and fro on some crazy waters. Was reason going to be enough? Maybe Hobbes had a point. Hobbes had a point that he thought some authoritarian Leviathan had to tamp down the madness. Maybe at a point that God is too dangerous an idea and God cannot be reconciled with a new philosophy of reason, with a new state based on reason. We'd seen in the 1500s and throughout the early half of the 1600s, war like we'd never seen it before. All that Spanish bullion, all that money coming in from the Americas is being used to buy cannons and gunpowder. We've got armies, we've got firepower like we've never seen before. The peasants are in on it now. They're waving their pamphlets, they're having their revolutions, they're joining the armies. Europe is rich beyond its wildest dreams and using all that money to destroy itself. Giant armies that have never before seen, we've never seen war on this scale. So this is important to understand. When Hobbes looks out his window, we have to understand that he sees literally what he says. It is the war of all against all. And that's exactly what he's seeing. The Holy Roman Empire, Spain, Italy, England, Sweden, Denmark, Holland, they're all, on some level or other, every single nation is either funding war, involved directly in war, and being destroyed by war. And what is fueling it? Well, obviously, politics and power. But what is the banner under which people are marching? What is the rallying cry? What's mobilizing the peasantry most of all, become new actors in this new kind of war, in this new kind of politics? It is God. Is there room for God in a reasonable world order? Or does this idea is simply going to cause destruction? Can this dualism, faith and reason, not hold together? Are they meant to just fall apart and disintegrate? So this is some very, very scary thinking that Hobbes is talking about. It's still haunting to this day, sort of the Hobbesian take on the world. And even though you could absolutely not say that Hobbes was converting people to atheism left and right, but he did unsettle them with his ideas. He did make them fearful and nervous and needful of something new, because Descartes has left the door open. Cartesian philosophy has left the door open for this. Hobbes is a modified Cartesianist. He took Cartesian philosophy, and this is what he came up with. It's a dangerous philosophy. Enter Isaac Newton. Isaac Newton is also born into this world of chaos. He's born in 1642. In his youth, he will see a regicide. When he's 9 years old, he will see Oliver Cromwell's republic established, where Oliver Cromwell starts off as a sort of rational Republican, but 11 years later, he's Lord Protector, that the middle-class participants who just wanted religious freedom have now become extremely radical levelers and roundheads, people who want to destroy society and make way for the coming of the next world. So Newton also has seen what Hobbes has seen. He has seen the world thrown into a blender. And this sort of turgid vortex at the center is this idea of God, which has been stirring up so much chaos that in 1660, when they decide, well, we really have had so much radicalism, they just restore the monarchy again. Charles II is restored back to the throne in 1660, and looks like England is not going to have its revolution after all. They do try to modify the power of this new king, but it is still very much a struggle. So we had a radical impulse and then a conservative backlash. So it looks like faith and religion are going to have to find their old accommodation with politics and with science, that there isn't yet a third way, a new way. Either you're too radical or you're too conservative. So let's talk a little bit about Newton's background so we can understand why it is that Newton gives us that third way. Newton's philosophy, Newton's science, Newton's religiosity is going to end up giving us that reconciliation that society needs. In order for the early modern period to become the modern period, we need this warfare, this chaos, this turmoil, this conflict to become reconciled. Not very auspicious beginnings. Newton is premature. His father dies before he's even born. His mother said he could fit in a quart mug. He might not even have survived. His mother remarries when he's 3, and he hates his stepfather. In fact, at some point in his adolescence, he actually threatened to burn the house down around both his stepfather and his mother. Needless to say, he spent most of his youth living with his grandparents. And so he had this deep sense of resentment and loss and anger and loneliness about being abandoned by his mother. His grandparents didn't understand him either. Even apparently, they couldn't stand Newton. How many people are actually hated by their grandparents? It takes a special kind of personality. So Newton is this very, very interesting person. And the reason why I'm even bringing his sort of lack of social graces or his intensity is because we're going to see how it plots the course of his life. His genius brings him into the center. His eccentricity pushes him out. His genius brings him back in. His eccentricity pushes him back out. And therefore, he is never allowed to be trapped inside the box. Therefore, he is allowed to exit this world intellectually, this world that cannot find a solution to its problems. And so his genius and even his difficult personality are all going to become necessary features of his revolution. When Newton is, well, he's supposed to be a farmer. They try to make him work on the farm, but every time they find him, he is sulkily slunk off, refused to do his chores, and he's found reading. So even though this is not someone who is necessarily destined for the intelligentsia, destined for university, his aptitude is recognized early on, and he's sent to Cambridge. At Cambridge, we don't hear all that much about him. He's quiet, he's reclusive, he's obsessive. And we know from the curriculum he would have been exposed to in Cambridge, that would have been Aristotelian, because Cambridge was very much under the influence of the church. Most of the faculty would have been priests. They would have been Anglican priests at this point, but it's still at the same time Anglicanism, high church was fairly conservatism. It purposely tried to walk a very middle road between Catholicism and Protestantism. And so they didn't go in for these huge changes. So the university system would have been Aristotelian and conservative. However, he was also, remember, able to read those philosophical transactions of the Royal Society. And those independent philosophers, those men of reason, they were all Cartesianists. Adaptations, right? They're not literally all Cartesianists, but we use Cartesianism to describe the body of philosophy known as mechanical philosophy. And its most important contributor was Descartes. So Newton would have been reading these philosophical transactions, learning about Cartesianism, learning about Kepler and Galileo and all of those ideas, but also he would have known about Platonism and Platonic philosophy, because obviously that's right in there in Kepler and Copernicus, but also Oxford had a stronger interest in Platonic curricula than did Cambridge. So already we've got Newton straddling 3 different worlds of knowledge, 3 different legacies, right? We've got the legacies of antiquity of Plato and Aristotle. Many ways they are part of the medieval system, but antithetical impulses, so there's conflict between those. Then we have this new radical rupture of Cartesianism, and Newton is spinning all three in his very capacious mind. Now, 1665, we get the plague. The plague comes to London, and he flees Cambridge, and he goes back into the countryside, and he gives himself a summer project. He's going to work on the laws of motion. He's going to work out his course in optics, and basically, you know, just casually start thinking about the program that is going to become the basis of modern science. And nobody really knows who he is, so he's not supervised or controlled. He's just going off with this young mind and these fresh ideas to hatch out his new theories. He comes up with optics. He's very excited about optics. In the 1670s, early in the 1670s, he goes and he takes the program of optics and he presents it at the Royal Society, like 1671. And remember, he's got some social skills problems. So somebody, Robert Hooke, makes fun, objects to him, and you have to think, who is this little upstart, this little country bumpkin coming in with a whole new theory about light? Who is this guy? So Robert Hooke, who's very sort of arrogant insider, thinks, I'm going to put this little parvenu in his place. He says something to Newton, and another person might have been able to process this insult and just kind of keep it in proportion, but Newton absolutely takes deep, deep emotional and catastrophic offense. He withdraws from the scientific community. He picks up his jacks and he goes home. He is not going to play with these people anymore. Now he's alone, but now he's angry. He's had it with these Cartesianists. And his mother dies, and he starts becoming very, very involved in Kabbalism and reading the Bible and trying to find if there are some proper astronomical interpretations that correlate to the predictions and revelations. So he is going really deep off the deepest end. That's our, the Newton we never learned about until later on. Also in his papers, something interesting, was a translation of the Emerald Tablet. Remember that document from the Corpus Hermeticum? Actually, it's a hermetical text. It wasn't in the corpus itself. But very important to Hermetic philosophy, as above, so below. So we know that when Newton turns his back on academia, and he turned his back on Cartesianism, and hey, go to your spot. Now, one of the things that he's exposed to through Hermeticism is a world of magical correspondences, of attractions. Remember, Hermeticism is based on that more Aristotelian cosmos, a world of affection and longing and attraction. Cartesianism, if you want to explain any kind of motion, even the motion that seems to happen at a distance, like we didn't have the word for it yet, but that obvious attraction, which is electromagnetism and gravity, Descartes had a mechanical explanation for that. He even explained that in terms of push-pull contact of helical particles you couldn't see. And Newton is sort of trapped in that mindset because he's thinking along with that Cartesian, in that Cartesian milieu of the Royal Society. But now that he's told them all to just go stuff it, and now that he's alone and he's angry and he's reading his Hermetic corpus, and he's thinking, I like the idea of attraction and mysterious affinities. I think this world is fundamentally more mysterious than Descartes can account for. And he marvels at the beauty of Kepler's laws. He would talk about Kepler's laws at the Royal Society. They were constantly, this is one of the big things they're trying to figure out is radial force and what keeps these planets moving. And this was a central thing, but they were trying to use Cartesian physics to explain planetary motion. It just wasn't working. So Kepler's second law. Kepler's looking at this. Remember, Kepler looks at the universe, and he looks at the Copernican system. He's got a priority that we would consider strange today. His priority is, why isn't the universe beautiful? Why isn't it harmonic? Why is it elliptical? Why are the planets those stupid distances from each other? Can't I make it pretty? Can't I make it harmonious? Can't I make it mathematically Pythagorean? So those are his agendas. And he does it. He does a great job. He gives us this second law of equal areas. Remember, we won't go into it again, but for every amount of time that a planet sweeps through its orbit, it sweeps out the exact amount of area from the overall ellipse it is circumscribing around the sun. So there's harmonious mathematics. And when he tries to understand what is making these planets go around the sun, he's not really that hung up. He's going to go with Plato. Oh, I think the sun is the world's soul. So the soul is that part that is about affection, emotion, that is about engaging physical matter. It's not pure nous or intellect. So that would explain, oh, the planets and the sun love each other, because that's what souls do. So the planets are in orbit around the sun through the attraction of love of the world soul. And oh, why is it an ellipse? Oh, it must be magnetism. They understood polarity. So they thought there's something magnetic about the tips of the planets that they either repel or attract. So he's not really hung up on understanding force. He's really thinking like a Platonist or a Pythagorean. He's hung up on geometry and describing cosmic shapes and structure and harmony in a fundamentally geometric way. But Newton wants more. He loves this theory, but he wants to complete it. He wants to understand force and what force means, how it functions, and find the mathematical expression of it. And he knows that it must somehow be related to Kepler's laws. And remember, this is Kepler's third law, which was the one that says, this is the one where the amount of time it takes a planet to go around the sun squared is directly proportional to the distance it is from the sun cubed. Don't worry about that, but that's Kepler's third law. Worry about that if you want to answer that on the test, but you can skip that question. So again, there's mathematical harmony, but how does this relate? It says nothing about force. Nobody tried to quantify this thing that's attracting the planets. And also, he's going for it. He's saying the planets are attracted to each other, not mechanically propelled by some kind of corpuscles. And he thinks about it, and he thinks about it, and he comes up with the inverse square law. Why are the planets the distances they are from the sun? Kepler gave us a reason that was very about geometric harmonies. Newton's going to give us a reason that is about force laws, the intensity of force, the intensity of attraction. He's going to give us his inverse square law. Later, he's going to call it gravity. But his inverse square law understands the distances that planets are from the sun according to the level of force attraction. So, say you have all the planets are attracted to the sun. That must mean the source of the attraction is the sun, and it must be the center of the sun. So his formula is incredibly easy. Why are the planets the varying distances they are? Well, if you have, say, R, so this planet R, this planet A, let's just call it whatever, Earth, okay, planet A. Let's just call it planet A. Planet A is 1 R. It's 1 radius from the source of the sun. So if you want to understand the intensity of that attraction, take the source, put it over 4 pi r to the 2nd power. And that's going to give you the intensity of that attraction. Now, what happens if you take that you take that same formula, but now you're going to planet B. And planet B is twice as far away. Well, you have the same formula for force. It actually should be the source times 4 pi r squared equals the intensity. And if you have it for, but this time it's 4 times 2 squared, so it's 4 times 4. So the planet B, is experiencing gravity at 1/16 the amount of intensity from the source. Planet 1 is experiencing it 1/4. Planet 3, which is 3r from source, and if you plug that into the same formula, you have 4 pi times 9, because that's 3 squared, is 136. Don't worry about all that. The only thing you should be getting out of that is that look how simple it was secretly. Look, that is a basic calculation. That is how long is that formula? It should read not force, it should see S over source over 4 pi r squared. That's it. That is a numerical description for the intensity of force that is holding the planets in orbit, describing why they are so far away from the sun with reference not to some sort of geometrical harmony, but with reference to force itself. Now, the exciting part is going to come now. It's one thing to get that whole inverse square law applying to the planets, but it's another thing to understand that whatever that mysterious force is that's making the planets travel around the sun, that is also going on here, as above, so below. So the forces that rule this sort of celestial sky are also the forces that rule the terrestrial Earth. Now, how does he put these things together? How does he apply the inverse square law that was first derived from looking at planetary motion as an astronomical phenomenon? How does he get that astronomical phenomenon is a description of force here on Earth? We're just going to use the apocryphal legend of the apple, okay? He's lying under the tree. The apple hits him. He notices that the apple is falling to the ground. And he has an understanding. The apple is attracted to the Earth. Then he looks up at the moon. The moon is going around the Earth just the way the planets go around the sun. The moon is attracted to the Earth just the way the apple is attracted to the Earth. Is it the same source of attraction? I mean, is it the same force? Can I plug it into my inverse square law? And here you have the mathematics. Okay, we know the inverse square law works on radius. So the apple's radius to the center of the Earth, to source, 4,000. Let's say it's 4,000 miles. The moon's radius from the center of the Earth is 240,000 miles. Is their relative attraction to the Earth describable in the same formula, source over 4 pi r squared? Oh my gosh, yes! Same force attracts moon and apple. It's the same force acting on both the moon and the apple, but as he predicted, the attraction towards the moon is only 136,000th the intensity, thank goodness, or else the moon would go crashing into the Earth just like the apple. So he's getting something very, very profound. Not only is he deriving terrestrial mechanics from the sky, he's also understanding that these are both fundamentally objects that are falling towards the Earth. Nobody would have looked at a planet that is going round and round. Galileo understood that inertia as circular. He thought it was just going around and round because that's what inertia does. But Newton understands, because of Descartes, that motion is much simpler. Cartesian motion is rectilinear. You move this way, you move that way, right? So it's angular. So he now understands there's two kinds of motion that is making planets stay in the air. There's the attractive motion towards the sun. In this case, that's rectilinear. You want to go right into the sun, just the way the apple wants to go right into the earth, but it doesn't, because there's another kind of motion governing planetary motion, and that is that more mechanical motion of just hurtling, right? If you, of something that is a cannonball is launched on another rectilinear path. Now, I'm going to give this example here of Newton's thought experiment. Now, Newton, to show this, that celestial orbits combine two forces that are present here on Earth. That's important. Two forces here on Earth, everyday, casual, boring forces, are the things that are making the planet stay in the sky. So he shows that if you shoot a cannonball from the mountain, but you don't shoot it very strong, see, that's A. It'll go up, and then it'll go back down. And just the way Galilean mechanics showed us, you want to combine two kinds of motion, that up and then that down. Put those together, it doesn't go like this, it's a parabola. Notice how the path of the apple is going up and landing in a different place, two kinds of motion coming together, describing a parabola. But what if the rectilinear, straight-up motion of launching your cannon was powerful enough that you could launch it high enough that the Earth, when it tried to pull it, the Earth wants to pull it back down, and you just shot it back up, it would just keep falling around the Earth. Before it was going fast enough that the Earth's gravitational pull was never quite strong enough to pull it out of its orbit. But the power of the original shot was not strong enough to break free of the Earth's orbit. These two kinds of motion balance each other, interact, and cause the Earth just to eternally just fall around the planet. Now, if you pictures of orbits C, D, and E are other demonstrations. What if you shot it really, really, really with lots of energy? It might go higher until it was captured by the Earth's orbit. And then he should have had one just, if you shot it so high and so far, it would escape the Earth's orbit. The Earth's gravitational attraction would never be strong enough. The intensity of the force, remember, which gets less and less and less. The farther away you get from the Earth, according to the inverse square law of attraction, the less intense. So that power gets less and less intense, so it's going to be, it's not going to capture the cannonball until farther out in the planetary, in its orbital pathway. And if you do it strong enough, it's going to overreach the intensity of the source's attraction and reach escape velocity altogether. That was his demonstration. Don't get too hung up on the details. Just understand that he is a genius because, first of all, he had the mathematical intelligence to understand that to calculate the actual source intensity of the Earth and the moon. He was able to calculate that and compare it to the attraction of between an apple and the Earth. He was also able to take celestial mechanics and apply them here on Earth and turn them into workaday, ho-hum terrestrial mechanics, right? Mechanical motion and gravitational attraction. He gives us, along with this new synthesis of celestial and terrestrial mechanics, three really basic laws of motion. Anybody can move ahead with these. These are pretty straightforward. You have he takes Galileo's idea of inertia, and he adapts it into his basic laws of motion. A body remains in its state of rest until it is compelled to change that state by force. Inertia, right there in the center of his program. That a change of motion is proportional to the force impressed. Proportional to the force. Oh, it's all quantitative. That every action, there is an equal and opposite reaction. So that we have right here, ball M1 hits ball M2. Now ball M2 is moving. but it looks like the force has been largely transferred from ball M1 to ball M2. So we have statics as well as motion. Ball M1 transfers the motion to ball M2, but then when ball M2 comes back, it hits ball M1, and then ball M2 is relative to ball M1 still. Now, what he's showing there is how something going to be very important to classical mechanics, that energy is transferred. It is transferred from matter, it's transferred from contact, that it moves throughout the universe, and that it can change forms. That's going to be a very important concept to modern physics. And it's all there in Newton's 3 laws of motion. So, to sum up, the Newtonian synthesis in terms of his science, it's more than that, but in terms of his science, gravitation is hugely important. Because gravitation is everywhere. It's a universal law. It synthesizes celestial mechanics and terrestrial mechanics. And it applies to every piece of matter. Every piece of matter is the same. It is a universe. This law of gravity applies to apples. It applies to tides. It applies to planets. It applies to stars. Everywhere, matter is the same. A universe, a homogeneous universe. Every particle of matter in the universe attracts every other particle that with a force that is proportional to the product of their masses and inversely proportional to the square of the distances between their centers. He tells us the formula for gravity. And he also tells us through the inverse square law the way that gravity, the intensity of that force, is dispersed throughout space. Now, we call it the Newtonian synthesis because he's bringing together so many different ideas. When he formulated both his mechanics and his law of gravity, he is drawing from Descartes, drawing from Galileo, drawing from Kepler, drawing from Copernicus. But he's also deep into alchemy and deep, in a way, into astrology, Aristotle, and Plato. He loves Kepler. Right? He loves the Platonic aspects of Kepler. He's studying alchemy, so he's deeply influenced by this notion of attraction, which is also a very Aristotelian notion. And we know that this is no stranger to the more sort of deep emotional mysteries of the religious disposition. Descartes wanted to experience his religiosity. He didn't want to have a godless world, but his relationship to God was going to be strictly through the mind, and it was going to bypass both faith and reason. That's just too radical. Protestants and Catholics are not going to go for that, and we are still in a world of Protestants and Catholics. Newton is obsessed with biblical prophecy. He's poring over scriptures for years and years. One of the ways to truth is scripture. And at the same time, he elaborates this philosophy, this larger philosophy, very much through the Royal Society. It is to them that he brings this body of wisdom he's been working on, the Principia. He brings it to them in 1687. If he didn't have them, there would have been nobody able to translate and interpret it. Even though his formulas are very, very easy to understand, the way he derived these formulas, it would have taken a community of dedicated philosophers to figure it out. And he had one, that science is this communal, collaborative, cooperative group of people who are working on a body of knowledge that is incomplete, and they come together guided by reason, but very much motivated to explore and discover, because the world is not ever fully known. It is fundamentally mysterious. And so when Newton brings his science to them, he brings a science that stands in relation to God's cosmos, in relation to God's mysterious creation, in a way that is fundamentally different from the Cartesian stance, which was almost more masterful, drawing God's world on a grid and telling God, see ya, we don't really need you anymore. Newton is deeply religious. He will not say what gravity is. He'll give you a formula for it. He'll make it part of the force physics of the universe that we have here on Earth, and it's everywhere, and it's attractive. but he won't tell you what it is, and he even leaves open the possibility this is God's presence in the universe. I can't tell you what gravity is, and we still can't. Newton says, no fingo hypotheses. I don't make hypotheses. Unlike Descartes, who did nothing but reason deductively, he didn't even make hypotheses. Descartes made statements, right? So Newton wouldn't even venture up hypotheses if he didn't have grounds for it. And so Newton's understanding of his relationship to the universe as a scientist was one of questioning, one of mystery, one of reverence. In his papers, he even writes about what he understands the essential role of the scientist is. The essential role of the scientist is to discover God's mystery. The more you know, the more you keep discovering, wow, God made 52 varieties of butterfly. Wow, God is so creative and great. Rather than trying to reduce the world to this Cartesian description of position, size, and matter, Newton understands the world is yet to be discovered. Now, when I say that Newton gives us our science, Descartes is important, but he doesn't quite get us there. Newton gives us our science because Newton gives us a science that is empirical, experimental. I gave you optics to read. That was extremely cool. I mean, he's got his prism, he's got his boards, he's poking holes in the boards, he's doing all these experiments. I mean, he's about investigation. He's about not knowing, and not knowing is okay because the world is fundamentally mysterious. God's creation is limitless. You can never really understand it, and that's okay. Should you stop trying? No, because practicing scientific discovery is a way of getting to know God. And how can you appreciate God if you don't really know how great his creation is? Book of nature, book of scripture. In conflict? No. Practically 2 pages of the same tome. So I already said all this, but I'm giving you a little list now because you have an essay to write. So here are the basic points. It is our modern science, right? Planetary and terrestrial, optics, motion, force. So he has a science for light, for force, for matter, for motion. It's mechanical because he is, to a certain extent, a Cartesianist. He loves Galileo, but it's also attractive. That's where we got the Hermeticism of Kepler and Aristotelianism. It's mathematical and physical. Newton's science advances through his mathematical knowledge. If he didn't have his infinitesimal calculus, he wouldn't have been able to do half the stuff he needed to do in order to understand these patterns and give you these laws. So it's not just physical, although it is physical. It's experimental. So you see how this is like our modern scientific program? It's mathematical, but it's also experimental. It's empirical. It has an idea that you observe with your senses. What you see, what you observe is really, really important. You can't be like Descartes. You can't do the whole thing with a calculator. But Descartes' mathematics are fundamentally essential. And it has a religious spirit that is one with its scientific spirit. It is both occult, the world is mysterious, and exoteric. It's mysterious, but you can understand it. There's 3 laws of motion and a really easy law of gravity with an inverse square law to explain its intensity. You can get it. So this is a new science. It's a new science that is somewhat dumped on Cartesianism and Cartesian epistemology. We need a new epistemology that is appropriately Newtonian. Descartes' rationalism, his emphasis on mathematics, his dumping on the senses is just not going to do it for modern science. It's not part of that spirit of empirical discovery and exploration. The ship is going out across the ocean to observe and explore. Everybody's not down in the deck just writing stuff. So John Locke is inspired by Newton. He's inspired by Newton. He's inspired by the wonder of Newton's discoveries, and he wants to find the philosophy of knowledge that undergirds what Newton has come to know. How did Newton know what he knows. What is the philosophy of knowledge? Like Descartes, he is radically skeptical. Because like Descartes, he has a job. Newton's philosophy is revolutionary too. He has got to create a point of view and a system of knowledge that doesn't reference tradition, authority, or Aristotle, or anything that came before. It must be a system of knowledge for these new men of reason. It must put them in charge. And also, it must be a system of knowledge that will give us a world of harmony and order and peace, because like Newton and like Hobbes, he has looked out his window and seen regicide and blood-soaked fields and madness. So Locke is very motivated to find the epistemology that will capture Newton's harmonious universe and find a way of articulating the harmony of that universe as part of a harmony of knowledge. But also, we know that Locke is one of our premier political philosophers. And unlike Hobbes' dark vision, Locke will give us a much more liberal, progressive vision of humanity. Drawing from Newton, he will formulate a system of knowledge, a natural system that will also give us a system of natural laws and a new way of understanding secular politics. And we'll have to talk about that on Tuesday.